everyone, and welcome to lesson 2 for fractions. I hope it's going well so far. If you're having any particular trouble, don't forget that you can always message me, send me a picture, send me a video, have your parents message me, whatever it might be, I'm here for you. Today I'm going to go over what you're going to be working on in your workbook today, and then also what you're going to be doing tomorrow. So I'm doing kind of like 2 days at a time. Okay, so first let's go ahead and focus on what it is you're going to be learning about today in your workbook. Today you're going to be looking at fractions or shapes and figuring out what fraction of the shape is shaded in. So let's go ahead and take a look at some easy examples first. Here I have 2 examples, and you're going to notice, we're going to go ahead and look, why don't we fold it here? We'll do one at a time. So for example, this shape. You're going to notice that we have a whole circle here, and then you're going to notice that one part is shaded in and the other is not. So remember that the part that is shaded is the part that you're going to count. That's going to go in the numerator. That's at the top. So I'm noticing that there is one piece that's shaded in. So that is going to go into my numerator. And then I'm going to draw the fraction bar line like this. And then in my denominator, it's going to be how many parts there are all together. So you're going to look at that whole shape and you're going to notice there's 1 and 2 parts all together. So the way that we say this fraction is 1/2 of the circle is shaded in, okay? Now let's go ahead and take a look at this example. You're going to notice that this circle is divided into more equal pieces than the last example. So you're going to notice that there are 1, 2, 3, 4, 5, 6 pieces all together, 6 parts, equal parts. 1 part is shaded in here. So again, the part that's shaded in, I'm going to put at the top because the question is what fraction of the circle or shape is shaded. So that is 1. I'm going to put that in the numerator. And then the denominator is going to be how many equal parts in all. So again, we counted, let's do it again. 1, 2, 3, 4, 5, 6. So we have 6 equal parts all together. 1/6 of the circle is shaded in. All right, hopefully that is making some sense. We're gonna do 2 more easy examples and then we'll get a little bit harder. So for this example, I have a square, and you're going to notice that again, 1 part is shaded. I'm going to write that in the numerator. And then can you guess what my number in the denominator is going to be? Remember that it's how many equal pieces there are in all. Okay, so if you said 4, you'd be correct. So we're taking a look. We have 1, 2, 3, 4 equal parts all together. So 4 will go into my denominator, and we say that 1/4 of the shape is shaded in, okay? So let's go ahead and take a look at our next example. Again, super easy. I want you to imagine I had some difficulty dividing the shape equally. So I just want you to imagine that it is equally divided, okay? It's not very equal, and I understand that's a little bit helter-skelter here, but we're gonna pretend. So we notice that, again, we have 1 part that's shaded in. I counted how many parts are shaded, just 1. And then in the denominator is going to be how many equal parts there are all together. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 1/8 of the shape is shaded, okay? All right, hopefully that's feeling good so far. I'm gonna get a little bit harder. I do have 4 more examples, so hang in there with me if you're like, this is too easy, Mrs. Borgia. Great, I'm so happy for you. Then you should be figuring this out before I'm even saying it, okay? And if it's tricky, then pay attention. You can always rewind and go back, all right? So I have this shape next. You're going to notice that more than 1 part is shaded in. So again, the number in the numerator is going to be how many pieces are shaded for these examples. We see that there are 2 parts that are shaded, so that number goes in my numerator, 2. And then in my denominator, it's going to be how many parts there are all together. So we have 1, 2, 3. So that 3 will go in the denominator, and the way that I say this is that 2/3 of the circle is shaded, okay? Let's take a look at this example. I know it's a little bit hard to see. Oh, there we go, here we go. Okay, so you see in this example that we have 1, 2, 3 parts shaded. That number goes in my numerator, and then that's at the top. And then my number in the denominator, the number at the bottom, is going to be how many parts all together. So you're going to see that there are 1, 2, 3, 4 parts all together. And the way that we say this is 3/4 of the circle is shaded. Okay, nice work. We're going to keep on going. We have 2 more examples. This is our next one. Again, I don't know why I had so many issues with dividing these squares equally, but I had some issues. So again, pretend that these are perfectly divided, all right? So you're going to notice here, I'm gonna move it, so there we go. So you're going to see that there are 1, 2, 3, 4 squares that are shaded in. That's my numerator. And in the denominator, it's how many there are all together. So we're gonna count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that one was a tricky one. I wanted to make it a little bit harder. We would say 4/16 of the square are shaded, okay? All right, last but not least, we do have this example here. Again, I understand it's not perfectly divided, so thank you for pretending. You're going to notice that there are 3 parts that are shaded. So I'm gonna put a 3 in my numerator. There are 3 parts that are shaded. And you're gonna notice that there are 3 parts all together. So that's your denominator too, okay? And the way that we say this, when I show you here, we say 3/3 of the shape is shaded in. 3/3, or that's the same as 1 whole. The whole thing is shaded in. You can see that I colored in the whole entire shape, okay? So that's that fraction that you see. All right, I hope that that made sense. That is your workbook work for today. I'm gonna put up here what pages you're working on for today. Tomorrow, you're going to be, I'm gonna take 2 of these that we worked on. Tomorrow, what you're going to be doing is you're going to be comparing fractions. Now, the thing with comparing fractions is that it is the opposite of what you learned about comparing numbers. When we look at fractions, you really want the bigger piece. That's how I've always taught fractions. Remember, we always think about fractions as sharing, right? And when you share, you want to share with the least amount of people so that you get a bigger piece. I'm going to show you what I mean. So for this example, okay, now I'm going to just open it up so you can see. You're going to notice that this shape is split into 4ths, and this shape is split into 8ths, okay? And this piece here is clearly bigger than this piece. I hope that you can see that and that makes sense, right? So you would automatically think, no, 8 is a larger number. 8 is greater than 4. 1/8 is bigger. But when you look at the picture, you have to be really careful. When you look at the picture, you see that when you share with more people, pretend like this is each a person here. When you share with more than one person, you're gonna get a smaller piece because you have to break up whatever it is that you're sharing into smaller pieces so everyone gets a piece. But when you're sharing with less people, 4 people instead of 8, when you're sharing with less people, you're gonna get a bigger piece because there's not that many people to share with, okay? So when I'm comparing 1/4 and 1/8, 1/4 is greater than 1/8. I'm gonna show you what that looks like here. Okay, 1/4 is greater than 1/8, and you can see that with the picture. 1/4 here is definitely a bigger piece than 1/8. All right, let's go ahead and check out that same example with the different problems, different numbers. So you're going to notice on this one, okay? For example, I want you to picture, if I'm sharing, these are cookies, pretend these are cookies, and I'm sharing it with 2 people, me and my friend. And here I'm sharing it with 6 people. I'm sharing it with my whole family. Which one is the bigger piece? I want you to think for a second. Take a look at the pictures. Which one's bigger? Okay, you should have said 1/2, right? With the less people you share with, the bigger piece you're gonna get. And the more people you share with, the smaller the piece is going to be. Okay, so it's the opposite. You would think, no, 6 is greater than 2. 1/6 is bigger. But when you look at the pictures and you really think about it, you're going to see that 1/2 is clearly bigger because you're sharing with less people. You're going to get a bigger piece. So hopefully this is making sense. When I go ahead and draw that greater than less than signal or sign, I'm going to go ahead and write it like this. 1/2 is greater than 1/6. Okay? I have included one other thing that might help you to understand the comparing fractions, because it can be tricky, okay? It's the exact opposite. You're like, no, this is confusing. So another thing that might be able to help you is this tool here. I sent this to your parents to print out for you, or you can even make your own if you want to. But this is what it looks like. And basically what you can do is you can actually cut these pieces out. I'm gonna go ahead and show you that right now. So you can kind of figure out, like in your brain, like try to really understand fractions and how to compare them. Because I think this is gonna be the trickiest part about fractions in all of this, is that is comparing. That's always been the trickiest when I'm teaching fractions to 2nd grade. So I'm gonna go ahead and quickly cut this out. And I'm gonna kind of show you how this works, okay? So I just cut out the 3rds and the 6ths here, and I'm just gonna put them on top of each other. So you can see here that I have 3rds and I have 6ths, and they're each the same length, because when you put 6 together, we have 1, 2, 3, 4, 5, 6, you have 1 whole. And when you have 3/3 together, 1, 2, 3, you have a whole, right? So they're the same length, they're the same, they're the same size, okay? So what's gonna happen is that when I'm comparing 1/6 and 1/3, I'm gonna go ahead and snip off 1/6, and I'm gonna snip off 1/3, and we're going to compare them. So when I compare these two fractions, you're gonna say, no, I think that 1/6 is greater because 6 is bigger than 3. And I'm going to argue that it's the exact opposite, okay? So when you are sharing this candy bar, for example, see that? Take a look. When I'm sharing with 6 people, I'm gonna get a smaller piece because I have to share with more people, okay? It's gonna be, oh, I have to share with more people, I get a smaller piece. When I have to share with 3 people though, we only have to divide that candy bar into 3 pieces, and so I'm going to get a bigger piece. So when I'm comparing, you can clearly see that 1/3 is greater than 1/6. So when you think about comparing fractions, I don't want you to think, oh, 6 is greater than 3, for example, and 1/6 is greater. It's the opposite. I want you to think about that sharing piece, okay? Hopefully this made sense to you. If it didn't, try to practice, print out your piece with the fraction bars and the tiles and compare them, and rewind this video if you need to go over those concepts. I'm here for you. If you have any questions, please message me. You know that I'm here to support you in any way that I can. And I hope that fractions are fun and that you're doing great. And I hope you have a really great day. Bye, guys.